We are going to talk about ratio and proportion. 1.618 is the golden ratio. It is considered an aesthetically pleasing proportion. So it is found in architecture often, it's found in nature, and what you see here are spirals that are formed using the golden ratio. So the difference between a ratio and a proportion is this. A ratio is a comparison of two numbers. Most often, a ratio is written as a fraction. It may also be written with 2:5. You read that as 2 to 5. And it may also be written with 2 and then the number, and then the word TO, 5, 2 to 5. All of these ratios are equivalent. The numerator, where the numbers are written side by side, must occur first to the denominator second. A proportion is an equation that sets two ratios equal. So you can see I have a proportion written down here that 2/5 is equal to 4/10. Here is an example of a magnification with scale factor 2. It causes our triangles to have a proportional relationship. So if you remember us talking that if I compare side xz to x prime z prime, it is based upon the scale factor. So the length of x prime z prime would be 6. Find the lengths of the other two sides. Pause your video. When you're ready to see the answers, press play. So the length of x prime y prime is 10. It is 5 times 2, which is the scale factor, and z prime y prime is 8, 4 times 2. The next thing I want you to do is compare the length of x prime z prime to xz, y prime z prime to yz, x prime y prime to xy. What do you notice? Well, you really should notice exactly what you found the first time, that, let's try that one more time, the sides are proportional. They are all in a ratio of 2 to 1. And that's something that we discovered in class on Wednesday. Now I want you to compare the areas of the two triangles, triangle XYZ and triangle X prime, Y prime, Z prime. I want you to notice both of them are right triangles. I know that that's the case because each triangle satisfies Pythagorean theorem. If I take the square of each of the shorter sides and I add them together, it's equal to the square of the longest side. So I know that they are right triangles. Find the area of the two triangles. Press pause on your video now, and when you're ready to see the answer, press play again. One more time here. So the area of triangle XYZ is 6 square units. That's 1/2 the base times the height. 1/2, 3 times 4, or 1/2 of 12 is 6. If you look at the area of X prime, Z prime, Y prime, it is 24. Half the base times the height. Half of 6 is 3, times 8 is 24. If I compare the area of the two, I take the area of X prime, Y prime, Z prime, 24, and divide it by the area of triangle XYZ, and I find that that's 4. I'd like you to think about how the areas relate given the scale factor that was used. Think about it for a second. Pause your video if you have to. When you're ready to hear more about it, press play again. So you'll notice that The areas of the triangle, the ratio of them is not the scale factor. It's actually the scale factor squared. Let's see here. So the area of a figure in square inches is equal to, and let's do this, I lost a prime mark. The area to the image of a figure is equal to the scale factor squared times the area, and this should be square units, of the pre-image. So if I find the area of my pre-image, I multiply it by my scale factor squared, I will get the area of my image. Turn your book to page 14, exercise 16. I would like for you to find these ratios. Press pause on your video. When you're ready for the answer, press play again. Okay, so I found each of these ratios. Xz over YZ is 3/4. X prime Z prime Y over Y prime Z prime is 6/10 or 3/4. You will notice in each of these cases that the ratios are the same. You will also notice I am not comparing XZ to the image of XZ. I'm comparing XZ to YZ. So if I take XZ over YZ, I choose the side that corresponds to XY, which is X prime Z prime, to put that in my numerator, and Y prime Z prime to put in my denominator. And you'll notice that all of the ratios are equal. All of the sides are proportional. We have produced with these transformations with magnification similar figures. Similar figures have proportional sides and congruent angles. Figures are similar if and only if. Wow. If and only if. I put 2 F's in there, and I really only wanted 1 because I spelled it out. Figures are similar if and only if there is a similitude that will map one figure to the other. And remember, a similitude is the composition of a finite number of line reflections and magnifications. Proportional n-tuples. On page 16, you will find this example. 2 n-tuples are proportional if and only if each component of one n-tuple bears the same ratio to the corresponding component of the other n-tuple. So you will notice that the ordered triple 3, 4, 5 is proportional to the ordered triple 6, 8, 10. So I looked at the first component 6 and divided it by the first component in the other ordered triple 3. And I did that again, 8 divided by 4 and 10 divided by 5. You'll notice that all of those ratios are 2. They are all equal, therefore 3, 4, 5 is proportional to 6, 8, 10. Properties of proportional n-tuples also appear on page 16. For all A, B, C, D in real numbers excluding 0, AB is proportional to CD if and only if each of these criteria hold true. So I should be able to take A and divide it by B, and that should be the same as C divided by D. So first over second is equal to first over second. The second property that always holds true if ordered pairs are proportional is that their cross products are equal. So if I know that A times D is equal to B times C, then I know that the ordered pairs are proportional. And finally, if you notice I take A over B, I can change it around like so. These ratios are also proportional. A over C, first component over first component, is equal to B, second component, over D, second component. On page 17, exercise 18, I would like you to take a look at it and try this problem. It says let pi be a plane, let P, Q, R, S, and T be distinct points in that plane. Let C be a point in the plane, and let R be a positive real number. Let P prime, Q prime, R prime, S prime, T prime be the magnification with center C, scale factor R, images of P, Q, R, S, and T respectively. For each of the following, I want you to find R prime, S prime, TS, and QR over RS. Notice each of those are lengths. So the length of RS, I want you to find an A. I want you to find the length of TS and B, and then the ratio of the length of QR divided by the length of RS. Press pause on your video. When you're ready for the answer, press play again. Okay, here are the answers. I took R prime, S prime, and I compared it to RS. And then I said that was equal to P prime, Q prime over PQ. And I filled in the blanks. So once I had my proportion written, I was able to cross multiply. I got 6 times R prime, S prime equals 6, 3 times 2. And then I divided both sides by 6, and I found R prime, S prime was 1. In my second example, I compared TS to the image of TS and PT to the image of PT. And again, I filled in the blanks, and then I simplified this. So this became 5 over 15, or 1 over 3, and then I cross multiplied. And then I was able to find out that TS was 4. In letter C, I was looking for the ratio of QR over RS. I know that that had to be equal to the ratio of their images. The image of QR over the image of RS, I was given those. So QR over RS is 5/9. On page 18 is a wonderful story about a Boy Scout, so I'm going to read it. On a brilliantly sunny day, a Boy Scout comes across a tree with a completely vertical main trunk. He notices that the ground round the foot of the tree is entirely flat and horizontal for several hundred meters in all directions. Taking a stick, which he just happens to have with him, and which is exactly 1 meter long, he stands it vertically on the ground in such a way that the tip of the stick's shadow coincides with the tip of the tree's shadow. So the picture would look roughly like this. And we'd like to find the height of the tree. We want to find R, the scale factor, and the height of the tree. Now, because we know our properties of magnifications, we know that if we have parallel segments, and this segment here has to be parallel to the tree here, and if I have parallel segments, then there is a magnification that will map the one segment to the other. So, since that's the case, I should be able to determine the height of the tree and R. Press pause on your video. Try to figure out the answer to the problem. When you're ready for the answer, press play again. So I knew there was a magnification, and since that was the case, I knew that the height of the tree over the height of the meter stick has to be equal to the distance from A to C, 25, over 1.25. So then I was able to cross multiply and solve for H. So I found that the height of the tree was 20 meters. And I don't have the scale factor written here, but I can figure out the scale factor by taking 25 and dividing it by 1.25, and that scale factor is 20. Yes, 20. Now what I'd like you to do is try the worksheet that is assigned, and the answers are online. The worksheet's online, and so are the answers to all those problems. Have a great day.